Hi, folks. Welcome to the Neo4j stream. My name's Will, and today we are continuing work on the GRANDcast FM podcast application built with GRANDstack that we've been working on. I guess this is the third session. Let me link the code to start off if you haven't seen that. So there's the code. It's this GitHub page that I have on the screen here. You can find the previous recordings linked here, episodes 1 and 2. In episode 1, we got started building out the podcast search functionality, is what we focused on in episode 1, using a service called the podcast index. And we built a GraphQL API to allow users to search for podcasts. Then in episode 2, we introduced the concept of users and subscribing to podcasts. And we sort of rolled our own authentication system using passwords and JSON Web Token. So now we have a GraphQL API. Any user can create an account, they can log in, get an authorization token, subscribe to podcasts, and then any user, whether you're authenticated or not, can search for podcasts. And what we want to do today is, okay, you can search for a podcast, you can subscribe to it, but we don't yet have the concept of episodes. So what we're going to do today is figure out how to parse these podcast feeds. Podcast feeds are XML documents that conform to the RSS spec. So we're going to figure out how to parse those and import those episodes into the database. And then we want users to be able to create playlists and add episodes to their playlists. So once we've parsed a podcast feed, I want to be able to see all the episodes for it as a user. I want to be able to add individual episodes to my playlists. I want to view the episodes of a playlist, and I want to view my feed, I guess. So I want to view in chronological order the latest episodes that I subscribe to. Cool. So that's what we're going to focus on today. So picking up from where we left off last time, working with user authentication, let's fire up our API. So we'll say start dev. That will create our GraphQL API running on the localhost 4001. Let's make that a bit bigger. So I have my authorization token from last time. So that looks good. I have that here. So we don't need to go through the login process again, although we could, although I may have forgotten my password. And then if we look in the docs tab, got the spinner, not sure why. Give that a sec. Make sure we have our database. Yep, so I've got the database running locally in Neo4j desktop. Good. So while Chrome is waking up here, let's talk a little bit about how we're going to approach this problem of parsing XML feeds and podcast feeds. So there's a few ways that we could go about this. We could sort of write some some code as a worker, maybe like some Python code or some Node code, and have a process that is checking the database for what are the podcasts that exist in the database, and then going out to the podcast URL, parsing that XML, and then calling the database to load it in the database. So that would be one way to do it. We then have to run these workers somewhere as maybe Lambda functions that get triggered every 5 minutes or whatever. Or we could have a server running somewhere that's just running these workers continuously. So that would be one option. What we're going to do, though, today is actually parse these podcast feeds using Cypher. So we're going to use the database actually to parse these and import data into the database. And specifically, we're going to use APOC again. We used APOC previous, oops, not nifty.com/APOC. I wanted to go to /labs and then go to the APOC documentation. So we used APOC previously in our GraphQL schema here for podcast search. So we used APOC to call out to the podcast index API. And APOC allowed us to make that network request to the podcast index API, set our authentication headers, read our credentials from a config file. So APOC is really handy. It's this library that extends the functionality of Cypher quite a bit. And if we look in APOC, import load XML is one of our options. So we're going to use the APOC load XML procedure to import XML data, specifically our podcast feed, and insert that data in the database. We could use the podcast index. So if we look at the docs, podcast index, if we look at the docs for the podcast index, there is a episodes endpoint. So we could fetch episodes from the podcast index as well. I want to see how difficult it is to parse these podcast feeds ourselves, though. I'm sure we're going to run into some feeds that are in different format, or maybe some that don't conform to the specification and things like that. So we'll have to work our way around that. But let's give it a try to see if we can parse these ourselves. Okay, so if we look at the documentation here, it looks like we have the URL to our XML documents. We call APOC load XML. Zoom in a little bit here. APOC load XML, passing in some configuration. We'll have to see what configuration objects look like. Simple mode. So it looks like there's simple mode. Let's go back to APOC load XML. So in simple mode, each type of children has its own entry in the parent map. Okay, so that's what simple mode means. And the element type is prefixed with an underscore. Okay, cool. So basically, what this procedure does is it takes XML and creates a map data structure. So like a dictionary or an object, and then returns that object, that map, for us to then work with in Cypher. And it uses these conventions to translate that XML document into a map. And so the configuration, we can say that we want to fail on an error while parsing the document, and whether or not we want to set any headers. So headers in this case would be if we have some maybe authentication headers we needed to add to fetch this. But in this case, most of our podcast feeds should hopefully be open and publicly accessible. Cool. So we shouldn't need to worry about that. If we look down at the example here, so here's a sample XML document. We have a catalog. We have books, and then each book has an author, title, genre, price, publish, and description tag. And here's an example of how the map looks when it is created. So you can see that that hierarchy is preserved. The type of the node in the XML document gets an underscore. Underscore type is the key and the value, and then underscore children to preserve that hierarchy. And then that's just sort of nested. Cool. So that is roughly how it works. Let's go into Neo4j. And first, let's see. I think we subscribed to some podcasts last time. Yep, got a couple podcasts. Let's make sure our GraphQL API is up and running here. So we last time added the ability to sign in, to search for podcasts, to show who the current user is. If I say current user, give me my username. This will use the authentication token that I've passed. It will validate it, look up that user in the database. After it validates that the token is properly signed, and give us the username. Cool. So I'm logged in as JennyCat. Let's see what podcasts JennyCat has subscribed to. So title, iTunes ID. So we've subscribed to Graphistania and the Connected podcast, and each one of these has a feed URL. So if we go to this feed URL, let's copy this and look at this in the browser. Drop a link to this in the chat if you want to see what this looks like. Zoom in a bit. Okay, so here's what this XML document looks like. This is the feed for the Graphistania podcast. So we have a channel tag, then we have some metadata about the channel. So that's information about the podcast. Then we have episode 11 here, which starts with an item. So we have an item tag, And then the item has things like a GUID. So this represents the podcast episode. So it has a unique ID, a title, a pub date, a link, some iTunes specific tags, a description. And then this is an important tag called an enclosure. And the enclosure has the type. So this is like the content type of the link, which in this case is the MP3 file. And then the length, I think this is the size of the file in bytes. And then we have the end item tag, and then on to the next one, which represents the next episode. So that is basically what makes a podcast. There's, let's see, the RSS2 specification is what I wanted to look at. There's a specification that every podcast feed needs to follow, and that is the RSS2 specification. So a podcast is basically any XML document that anyone can put out there that conforms to the RSS2 specification that links the audio files in that enclosure link. So the neat thing about podcasts is that anyone can publish these, just create your own podcast feed and start putting content out. RSS stands for the really simple syndication. And if we look at the specification, we'll see the things here that the Graphistania podcast conform to. So the channel element is required to have title, link, description. There's a bunch of other optional things, but it needs to have at least those required elements. So like you saw that it has additional elements that are specific to iTunes. So the iTunes category, which is going to be not necessarily included on all of these. So we want to make sure to handle that. Anyway, then the item element, this is an important one as well. It has title, link, description, enclosure, GUID, pub date. We saw those. Cool. So that is what we're interested in. Let's take this feed URL and jump into Neo4j and see if we can figure out how to start parsing this using Cypher. So we said we wanted to use APOC load XML. This will yield value, and value is going to be this map object. Let's go ahead and just return that and see what that looks like. So now this is the object we're going to be working with. So you can see we have a top level type. That type has children of type channel. The channel will then have children as well, which are going to be like each of the episodes, which are going to be of type item, and then the channel also has metadata associated with it. So let's start pulling out some of the values that we're interested in. We already have the podcast information, so the metadata associated with the podcast itself, so like the title, description, the feed URL, this sort of stuff. We already have that from our call to the podcast index API. We've already saved that in the database, so we don't need to grab that. So let's just start iterating over the children, which are going to be the child elements of this XML document. We don't really need to name these. So let's say we want to bring through we want to filter out, I guess, where the type is item. So I want to filter through the children of this foo element where the type is item, and those are going to be our episodes. So let's return those. Okay, cool. So now we have a array of episodes. This looks good. So we see we have information that we need for each episode. So now let's unwind over each episodes. And then let's pull out some of the data that we need here. So let's filter episode.children. Let's filter where the type is title. So where the child element of item is title. So that's going to be this object. Let's get the text as title. And then we're going to repeat this pattern, filtering the children where the type is, what else do we have? Summary. And now this this extract, let's look at the Cypher ref card. And I'll drop a link to the Cypher ref card in the chat here. That's a handy resource to see all the different syntax for Cypher. So that list expression that we're using is doing a filter where the predicate is true, right? So I want to filter on this object, and then it gives me back a list in this children array, right? The reason I have to grab the first one is because there could be more than one object in this children list that match this predicate. There's most likely not going to be, right? Because if we're conforming to the RSS specification, we should just have one of these. Anyway, that's why we're doing that. So this is going to be the summary. Filter children where the type is x dot underscore type. Summary, we have the link. And we want the text. Next in episode children where x dot type is, what else do we have that we want? Image. That's going to be our show art. X in episode children where x dot underscore type equals the enclosure. That's an important one. So the enclosure, this is going to be the MP3 file. We also want to filter for the type of the enclosure. I think you can include kind of arbitrary enclosure URLs. So let's also filter where the type, let's say, contains audio. So this is like the content type of the file. It could be audio MPEG. I don't know what the other formats are, but could be audio something else maybe. So let's do that. Grab the first elements dot URL is what we want this time instead of text. Underscore text is like for the simple tags. If we look at what this enclosure, the enclosure itself is a here we go. So the enclosure is a self-closing tag, right? The enclosure doesn't have any text values like where description has the text value here. It just has, I don't know what the proper term for this is, but like the metadata associated with the tag, type, URL, and so on. So that's why we're grabbing the URL value instead of the text value, because the enclosure tag itself doesn't have that text value. We'll say this as audio. Okay, X in episode dot children where X dot type equals, okay, we got the enclosure, we got the image, we got the summary. Duration, I don't think we need. Oh yeah, let's do pub date. Pub date first element dot text as pub date, so the date the episode was published. And episode children where the type is, what else do we need? We could definitely make use of the unique ID, the GUID. So let's grab that. Okay, and let's return star to see if this works. Sort of. So we have episode title, summary, the pub date, the link. So the difference between link and the audio file, the link is like the landing page for the website or for the episode. So in this case, oh, that's very loud. It startled me. In this case, the link is hosted on SoundCloud. Okay, but GUID and image didn't come through. So what did we do wrong there? Oh, well, GUID I mistyped as guide. So here's the unique ID for the image. Oh, image is not stored in text. It's stored in the href. So instead of text, it's stored sort of inline in that tag as href. Cool, there we go. Now we have the image file for each episode. And the audio file, let's make sure that, okay, well in the browser that tries to download it. Okay, that's fine. We'll have to figure out how to play those when we start building the front end of our application. But okay, cool. So we've got the basic information now we need for each episode. I guess let's test this on maybe another podcast. Let's try this out on Connected. This should work because these should both conform to the same RSS2 specification. So we've got audio file, unique ID, it's the URL, that's fine. We've got image art for the episode, a link, pub date, summary title. Cool. Looks good. So what we want to do now is actually add these to the database. Let's go ahead and do that. So in this case, let's match. Let's just go ahead and do this for all podcasts that we have in the database. We only have 2 podcasts in the database, so this should be fine. Which we're storing, I think it's the feed URL property is where we're storing the feed URL for each property. So match on all the podcast nodes. Then for each podcast node, which is just going to be 2, I don't know, maybe 3 that we have in the database so far. And remember, the only reason we have just a couple of podcasts in the database is because we're only creating a podcast node in the database when a user subscribes to it. So because we're doing search through the podcast index, we don't need to store like every single podcast in existence. We only need to store the ones that our users are subscribing to in the database. And that helps us as we're building out this sort of podcast aggregator where we're parsing all of these podcast feeds. Well, we only need to parse the feeds that our users have subscribed to. There's no point in us parsing other podcast feeds. Okay, so now let's create an episode node for each one of these. So we'll merge to avoid creating duplicates since we have the unique ID for each episode. We'll set the episode title, the summary, the link, the image, the audio file, just, I guess call it audio, the pub date, and we already set the GUID, so that's good. And then we'll say that the episode has an incoming relationship called has episode connected to the podcast up here. Oh, let's make sure we bring. So anytime we have a with statement, we need to explicitly bring through any variable that we've defined that we want to reference later. So let's see if this works. Invalid input. What did we do wrong there? Merge episode has episode. Oh, extra comma. There we go. It says we've added 454 labels. Let's find some episode nodes. Cool. So here's an episode node. This is an episode of the Connected podcast, and we're storing all the properties. Let's deal with this pub date. So this pub date, this is now just a string, but we want to store this as a date time type in the database so that we can do like ordering and filtering by it. So we need to cast this during our import to a datetime object. If we look at, let's see, Neo4j datetime types. I was just looking at this for another project. Temporal values, instant types. The developer guide on this, I guess, is a good place to start. So we can, let's make this a bit bigger. There we go. We can call the date time or the date function to create either a date object, which has year, month, day, or a date time, which is year, month, day, as well as hour, minute, second, millisecond, time zone. There's also a zoned or a local date time, which does not include the time zone. And the docs describe how we can create these. I think the docs refers to, temporal instant type creation. So depending on the type, there are a few different ways that we can create these. We're going to be working with date time. So we don't want the current. We want to create date time from an existing string, which we can do in a few different formats. However, the format that we have, which is, we look at the specification. Where is pub date? Pub date conforms to the date and time specification of RFC 822. If we look at that, it's a bad link. RFC 822. Anyway, this is an example of RFC 822 format, which is what all of our pub dates should be in. So what we're going to do is actually use another APOC function. I think this one is APOC date parse, I think is what we're after. Yeah, here we go. Where APOC date parse takes a string, the unit that we want to parse it to. So we're going to parse this string and create the equivalent milliseconds since the APOC format, and then it takes a format string, which is used to define the format of the string that we're reading. So there's lots of different formats. So we need to figure out what the format is for the RFC. What was it? 822. So RFC 822 Java date format. And if we take a look at Stack Overflow, here is an example that has the date format that we're looking for. So let's try this. So if we say, let's return APOC date parse, the string we want to parse, 2 milliseconds, and then here's the format that we grabbed. Let's grab this pub date example. And we should get back this date in milliseconds. Cool, which we do. And so now to convert this to a date time object, we can call the date time function and pass in epoch millis, I think it is, as an object. And we should now have a date time type. Missing a closing parenthesis, it looks like. Cool. So this is November 4th, 2020 at 11:30 p.m. GMT. Great. So let's copy that, and where were we here? So now when we save the pub date, we're going to say call APOC date parse on the pub date. If we run this again, because I'm saying set instead of like on create set, where we would only update those values if we were creating a new episode node. But because I say set, so when we use merge, there's two options. There's on create set, which will only then update these values in the case where this episode node did not exist. And that's useful if these values are not changing, or if maybe it's expensive to compute these values and we don't want to do it every time, especially if we're loading large data sets. We want to use on create set often, so we don't spend a lot of time updating the property store with these values. And then we have another control flow, which is on match set, which this is useful if maybe we want to like increment a counter or something like that, where if we've seen this before, we see it again. And then if we just say set, then in either case, if it's creating or matching on this episode node, we'll update these values. And I'm going to leave this as set because these podcast feeds can update, right? So people can push up new podcast files. If there's a mistake, they can update the show notes, things like that. So we'll make sure to always overwrite any existing values that we had. Cool. So we ran that, and now if let's go back and look at some episodes. If we look now at an episode, we should see, cool, now this is a date time type instead of a string. Okay, cool. So we parsed all these episodes. That's nice. How do we keep up with this, right? So our users are going to be searching and subscribing to new podcasts. We want to make sure that we're also checking these feeds to see if there are new podcast episodes being released for the ones that our users are subscribing to. So one thing we can do is run this as a background job. So if we take a look at APOC, what section is this in? Background operations. And background jobs. So we can run this statement as a background job. So every, I don't know, maybe 5 minutes, it might make sense to parse our podcast feeds. Of course, we need to be a bit smart about how we do this. We don't want to just try to do this all in one big cipher statement of something. If one of the feeds fails to parse, it can't fetch it for whatever reason. Maybe it doesn't actually conform to the specification. We want to make sure that we have some error handling there. So maybe we just have something where we store the last time that a podcast feed was parsed, and we're just grabbing the most recent one and continuously checking for new episodes, that kind of thing. So that's one option, that we can have these running in the background and managed as an APOC background job. But what about for new podcasts? So when a user first subscribes to a podcast, they want to see those episodes right away, right? So anytime that a new podcast is added to the database, we want to parse its feed and add all of its episodes. And there's a couple ways to do that. One would be using a trigger. So we could use an APOC trigger so that anytime a podcast node is created, then we parse the feed and add any episodes for it. And we could do that by defining an APOC trigger. I'll link the page for this in the chat. So that'd be one option. I think another option, though, if we look now at the code for our GraphQL API, another option would be to do this in the mutation when we subscribe to a podcast. So kind of similarly to how when a user subscribes to a podcast, we're calling out to the podcast index to fetch the details for that podcast. I think right here, what we'll do is parse the podcast feed URL and add any episodes during this mutation, so that way they are available immediately for the user to see. So let's do that. So I'm going to take this Cypher statement that we wrote and add it to the subscribe to podcast mutation. So this is the mutation that we call when a user wants to subscribe to a podcast, passes in the iTunes ID of the podcast. We then, using Cypher to define our custom logic here, call out to the podcast index API, look that up by iTunes ID, and then create, well, we merge, so we get or create the podcast node, set the details and these values we get from the podcast index, and we create this user subscribes to podcast relationship. And what we want to do right here, I'll paste in the Cypher query that we just wrote, which is then going to parse that XML feed and start adding episodes. Let's see. Let's make sure we did this right. So a user, I guess we don't need to match on P. We've already merged on the podcast node. We'll call I think we need, let's drop the user. I think we need, in between a merge and a call statement, we need a with, just to be explicit about what we want to pipe through there. So we'll say with P, so only bring through the podcast node. Unwind and start parsing. Oh, and then because we're in a Cypher directive field, I think we need to escape our double quotes here. So let's escape all of those. I think we have, yep, 2 more over here. I could do a find and replace, I guess, but we don't have that many. Here, here, and here. And let's see if that works. So we'll save that. Let's go back to our GraphQL API. I guess we need to search. Say podcast search. Search term. Search for the Accidental Tech podcast. That's another good one. Let's get the title and iTunes ID. Cool. So now let's subscribe to this one. So we're going to do a mutation. Subscribe to podcast, passing in the iTunes ID, and then that returns the podcast object. Let's make sure we don't have this one in the database. So we have we just have Graphistania and connected. So let's run this. And okay, it returns the podcast. So now if we go to the database to refresh, we can see, okay, here's the Accidental Tech podcast. So we added that to the database. If we traverse out, we then see episode nodes that we added. So Jenny Cat subscribes to the Accidental Tech podcast. And then here are a bunch of episodes that we parsed. Neat. Cool. Although I don't see a summary on these. Let's go back to the feed URL. Or let's look at the feed URL for this one. So the summary should just be in a summary element. Let's zoom in a bit. Do we have summary? Not as an element. These are just, those are just the use of the word summary. Let's see. Is summary not one of the required elements? So text input, elements of item, description. Oh, maybe description is what we should have used instead of summary. Description. Yes. If we change this to description, and then let's subscribe to the podcast again. That's okay. It'll just merge over everything without creating duplicates. Let's refresh here. Look at some ATP podcast episodes. And now, cool. We grab the description field. In this case, ATP publishes the description field as HTML, which is fine. That's good. We can just embed that HTML when we start building our front-end application. Cool. So that is podcast episodes. What else do we need to do? I guess we need to deal with the playlists, right? So we want to create a playlist, and then we want to add episodes to a playlist, view our subscribed, view episodes that we've added to the playlist, view our feed. Oh, maybe let's do that first, is our like episode feed, right? So I subscribe to podcasts, and I just want to see my feed. So of all the podcasts I subscribe to, show me the most recent episodes across all of those. Maybe that's what we want to do first. So let's create a new query field. Let's call this episode feed. Let's paginate this. So we'll bring in first and offset. Instead of making these required, let's just give these default values. offset. So by default, let's return the first 10. And these are going to return podcast episodes. And because we only want to show the feed for the currently authenticated user, we're going to define our logic using the Cypher schema directive so we can take advantage of that user params object. Remember last time we added this sort of middleware here where we parse the auth token that's passed in the GraphQL request. So that's this token. We verify that token and we grab the user ID out of that token. So this user ID value is available in any of the Cypher queries that I attach in my GraphQL schema in the Cypher params object. So we're going to use that here. So statement. So this is going to match on the authenticated user. So let's look them up by ID. And then I guess we're going to look for any podcast that this user subscribes to. And then we want any episodes that the podcast has. And we're going to return those episodes ordered by pub date descending. We could parameterize this. I don't know if there's a use case. I think we typically want our most recent episodes in the feed. We'll then skip offset limit first. Skip limit. Yep. Okay. If we save that, I think we still need to add the episode type though. So I think that's the error we're getting here that doesn't know. Yeah, unknown type episode. It doesn't know what an episode is. So let's say type episode. Episode has an ID, a pub date. That's a date time object. What else? We had a summary, title, link, the image URL, the audio file. We just called that audio. And then it's going to be connected to a podcast. Let's add that. So we use the relation directive to include the name of the relationship type, they're called, not the name of the relationship type, which has episode that connects a podcast and episode. And the direction is coming in because it's coming from the podcast to the episode. Okay, so now if I refresh GraphQL Playground to pick up the most recent type defs, I should see episode feed now. Notice also that it's added episode and podcast query and mutation types. Well, I guess we had podcast before. It now has episode, but now we've added the mutations to create relationships between episode and podcast. Okay, so I should be able to say feed, episode feed. Let's not we'll just use the default first 10. I should get title, summary, and then I want to know the name of the podcast. And then let's also grab the pub date so we can make sure that it is in the right order. And cool. So this is episode title 409. And remember, the summary in this case was in HTML. That's why that looks like that. So this is an episode of Accidental Tech Podcast from 12/17. That's today. And then an episode of Connected from yesterday. And then 408 feature headphones, which is from Excellent Tech Podcast from a week ago, and so on. Cool. So if we think of in our client application, once we build the front end for this, what we want to do is like show the user their feed where they're seeing, okay, here's all the new episodes that I have. And then maybe I don't want to listen to them now, but I want to add an episode to a playlist. So I like click on one of the episodes in the list, add to playlist, and then it's added to the playlist. And later on, I can view and listen to the episodes in that playlist. So let's create the functionality for a user to add a playlist. So I'm going to go down to the mutation type, and I'm going to again define a custom mutation where the logic is using a cipher directive rather than take advantage of the generated mutation. So if I just add a playlist type up here, let's go ahead and do that. So type playlist. What is a playlist going to have? I guess it'll have a name. I guess that's really all it needs, right, is a name, and then it'll have episodes. And episodes are connected to playlists through a relationship called in playlist, let's say. And the direction is going to be coming in from the episode to the playlist. So if I do this, so I'll save that to refresh the API. I'll go over to Playground, refresh Playground. And now I have a playlist query field that's added. And I also have a create, delete, add playlist episode, so I can connect playlist to episode nodes. So I have all of those generated CRUD operations for the playlist just by creating its type here, but I don't actually want to expose those because a playlist is specific to a user, right? So I don't want to just add these and let any user access the playlist. One way we could handle this is to use the GraphQL authorization directives. If we've seen those, let's go in the docs to authorization. Yeah, so we could start adding authorization rules in our schema. Drop a link to that in the chat. That would be one way to address this. What I want to do, though, is I'm just going to define the logic in Cypher so that we can exclude these types, the playlist, similar to how we excluded the user and the auth token, because we don't want those to be included in the generated mutations and queries. So I'll add playlist to the exclude configuration here. Now if I go back to Playground, refresh, look at the docs, playlist query field is gone, as well as the playlist mutations. Okay, so we've defined the playlist type. Let's add a create playlist mutation field. It's going to take a name argument and return the playlist that it just created. And the cipher statement. So what this is going to create a playlist node and then connect it to the currently authenticated user to say that the user, I think, what did we say in our data model? Do we still have that here? I think we said owns a user. Yeah, a user owns a playlist. I think instead of has episode, let's say in playlist. Yeah, so something like that. Okay, so let's first match on the authenticated user. So look them up, cipher params dot user ID. And then let's merge this playlist. Okay, and this is going to merge on the whole pattern here. So if this user does not own a playlist of this name, it will create a new playlist and relationship. And then we return the playlist. Okay, so we can create a playlist. The next thing we want to do then is add an episode to it. Add episode to playlist. We need the name of the playlist. And we need the ID of the podcast. And let's return the playlist, I guess, from this mutation. I guess that makes the most sense. So we need to match on, again, we want to make sure that we're using the currently authenticated user. So we want to match on the user by ID. Looking up cipher params dot user ID, where the user owns this playlist. Look it up by name. Then we want to match the podcast episode. So look that up by ID. And remember, these GraphQL field arguments that the user passes at query time, those are passed into the annotated cipher statement here as parameters, as cipher parameters. And then we'll do a merge to avoid creating duplicates to merge this relationship that says the episode is in playlist and return the playlist. Okay. Should we test this? Let's test it. So here's my episode feed. I'm gonna remove the summary field so it's a bit easier for us to see here. So I'm in the app. I open the app, gives me the episode feed. So here's all of the podcasts that I see. Oh, I guess I need the ID for the podcast. And I see, okay, here's this episode of Accidental Tech Podcast. I want to listen to that on, I don't know, my next road trip. So now what I'm going to do is call a mutation. First, I guess I need to create the playlist. Call this the road trip playlist. And it just returns the playlist, which just currently just has a name. And now I want to do another mutation, which is add episode to playlist. So the name of the playlist is the one I just created, road trip. I called this podcast ID. It's more like episode ID. Whatever. That's good enough. And what does this return? This returns the playlist. We have a little error here. What did we do wrong? An extra, we had a missing curly brace. Okay, so let's run that. And cool, now it says here's your playlist called Road Trip. It has this episode. Let's add another episode to it. Go back to our podcast feed. Here's an episode of Connected. Now let's add that to our road trip playlist. So we'll pass in the episode ID there. And cool, now I've got 2 episodes. If I look in the database to see what's going on in the database, let's close these frames. Just refresh to close all those frames there. We don't need to keep those as rendered. If we look in the database, we have a playlist node called Road Trip. It says Jenny Cat owns Road Trip, and there's 2 episodes. One of Accidental Tech Podcast, one of Connected in this playlist. Cool. So I think the other thing that's missing is like a view all of my playlists, right? Because here I could see these episodes were in the playlist, but that was just as a direct result from the mutation. I probably need like in my app, I'm going to want to have like view playlist and then select playlist to view the episodes for each playlist. So if we go up to the query type, let's add another query field. Let's just call this playlists. So this is going to return the playlists for the currently authenticated user. So again, we're going to match on the user, looking them up by ID. And we're going to find any playlist that they own. Playlist. And we'll just return the playlist. So the nice thing about the cipher generation logic in the Neo4j GraphQL.js library is I don't need to project out everything that I want to return in the selection set from this playlist query field. So I'm going to say, oops, I want curly brace, not brackets. So I'm going to say playlists, give me the name of the playlist. So that's kind of like this cipher statement. But of course, the playlists, well, they have episodes, and episodes have title, summary, the audio. They're connected to the podcast that has a title, description, right? So I can build up more complex selection set, but I don't need to specify all that in this query because Neo4j GraphQL.js, the library we're using to generate our GraphQL resolvers, knows how to generate the cipher statement to fetch all of the additional fields in the selection set. And if we look at the cipher query that was generated, well, this is it here. Cool. Well, now I've got my playlist. Here's road trip, so I can grab the most recent episodes on this road trips playlist, and here's the audio file for the playlist that I'm interested in, or the episode I'm interested in, and I can start listening to that. So I think that is everything that we wanted to cover today. We figured out how to parse podcast feeds using Cypher. So we added the logic here to our subscribe to podcast mutation that when a user subscribes to a podcast, to go out and fetch the podcast feed URL, add the episodes to the database. We also added the concept of playlists to our GraphQL API. So a user can create a playlist, they can add episodes to it. All of that information is private and specific to that user using the user authentication functionality that we built last time. Cool. So I think we will, I think we'll call it there. So I'll push up the code for all this to GitHub. Again, the link is right here. Drop that link in the chat. I've also been writing up each of these live stream episodes as blog posts. So for example, you can find episode 2 that we wrote up here as well. If you prefer to consume that in blog form. Basically showing last time how we added authentication functionality. Cool. I'll push up the code and check out the code if you're interested. I've also recently created a newsletter. I'll drop a link in the chat to that if you want to get these sort of updates in your inbox, just posting links to blog posts, things I'm working on, that kind of thing. So if you want to keep track, that's a good resource as well. Cool. So this is my last live stream of the year, I think, since our next 2 regular Thursday times fall on Christmas Eve and New Year's Eve. So we'll pick back up at the beginning of next year, the first week in January. And I think it's time to start building out some of the front end of this application. We've built out the GraphQL API to the point where we have some good functionality, but now we need to think about the front end of our application. And I think that we'll take a look at using Next.js to do this. If you're not familiar with Next.js, it is a framework built on top of React, so kind of like a batteries included framework built on top of React. So that's what we'll start with next time, first week in January, building out the front end for this application. In the meantime, if you have any thoughts on features you'd like to see added, feel free to let me know on Twitter. I think is probably the easiest way. I'll drop a link to my Twitter here. Just ping me on Twitter with any feature suggestions that you'd like to see us working on in these live streams. Otherwise, hope everyone has a good end of the year, and we will see you after the holidays and start working on the front end, which should be pretty fun because we'll actually then be able to start listening to the podcasts that we're subscribing to. Cool. Well, thanks a lot for joining today, and we'll see you next time. Bye-bye.